Yeah.
Okay.
Hey guys.
So the top of a 25-foot ladder is sliding down a vertical wall. Okay, so right, here's my wall.
That's not
Right.
good at all.
That's not good.
Hopefully no one's standing on
Yeah.
it.
All right, the ladder is 25 feet. Okay.
Did you see the TikTok where it was the family put like the animatronic of like the dude falling off
They
the
call
thing?
the fire department.
Yeah.
What does it look like, Jordan? Yeah, it sure is a triangle.
Oh no.
Recalculate.
Okay.
Protractor thing out.
All right, a 25-foot ladder, let's focus, Carson, is sliding down a vertical wall at a constant rate of 3 feet per minute. It tells us it's a vertical wall because then we can make the assumption that it's making a right angle, okay? So it is sliding down, so I'm going to say that I'm given, right, we're going to call this y and we'll call this x. I'm given dy dt. Right? What's dy dt? But it's going to be negative, right? Negative 3 feet per minute. Okay. When the top of the ladder is 7 feet from the ground, what is the rate of change of distance between the bottom of the ladder and the wall? So we're going to call this z. Okay. When the ladder is 7 feet from the ground, right? So talking 7 feet here. What is the rate of change in the distance between the bottom of the ladder and the wall? So what are we looking for? The rate of change of the distance between the bottom of the ladder and the wall. So that's this distance here. Yes. We're looking for dx dt when what? Y equals 7. When y equals 7.
So then what's the point of z?
Okay.
The top of the ladder is 7 feet, 25.
The top of the ladder is 7 feet from the ground. Here's the top of the ladder. That's the length of the ladder. Maybe we don't need z. I don't know.
Oh.
Okay. Okay.
Wait, what's sliding down?
The ladder.
The ladder.
Oh, here's the
Okay,
ladder.
good.
So oh, so a ladder's on it, and all of a sudden it's slipping and it's going.
Like in Clark.
Yeah. What? Wait, Faith. Okay, look. I get it now. I get
Faith
it now.
doesn't really
I'm
run
sorry,
ladders
I
much,
get it
so.
now.
All right. What do we know? This is a triangle. And we know that a triangle, x squared plus y squared equals
R squared. Z squared.
z squared, right? And z squared is giving us,
25.
right, z is just 25. Right, z squared is 25. All right?
Yeah.
Oh, so you just called it 25Z. It wasn't like a specific part.
No, I didn't need a z. I'm sorry. I didn't need z, and I didn't know that until I started the problem.
Oh, but 25 is Z squared. What did you know?
Whatever.
Y squared. So 25 is Z squared.
Okay, come on, guys. Let's focus. All right? Look, if I am trying to find the distance between these 2 points, I would take the square root of x squared plus y squared. That would give me the distance between those 2 points. Right? Okay. Okay. So let's see here. So I have x squared plus y squared equals 25. So there's my formula, right? Let's see what happens with it and see what information we need. Taking the derivative, 2x dx dt plus 2y dy dt equals the derivative of 25, which is 0. Okay.
Oh, and we know dy dt.
I'm trying to find dx dt. I don't know x. And actually, I don't know y either, right?
Y equals
Oh, y equals 7.
And
Okay.
we also know dy dt.
Okay. So I know dy dt. I know y equals 7, and I'm looking for dx dt. It's the x that I'm missing. So how can I figure out x? Yes, right? We know that
If that's 7 feet high.
x squared plus 7 squared, right? We're saying that this is 7. X squared plus 7 squared equals, what was it? 25 squared. A squared plus b squared equals c squared. Okay, yes.
Why is it 25 squared there, but not 25 squared there?
It should be squared, but it doesn't matter because when I take the derivative, it's still 0. Okay. It does, so it doesn't matter because when I take the derivative, Carson, please, come on, we're trying to get done here. Yes, Lauren.
Why aren't we just plugging in what we know?
Okay, good question. So because when we looked at what we knew, we discovered that we don't know x. We need x.
Oh, because we just have two separate variables.
Right, because we're trying to find dx dt. We know y and we know dy dt. So now we have to go and work over to the side and try to figure out what x is. Okay, so when y is 7, we get x squared plus 7 squared equals 25 squared. So I get x squared. Oops, I'm just going to, I didn't write the in-between numbers. So this comes out to be x equals 24. Okay. So now I can go back and we've got 2 times 24 dx dt, equals 2 times 7 times negative 3 equals 0. 48 dx dt minus 42, right? So we get 48 dx dt equals 42. Dividing by 48. 42 over 48, which is going to be 7 over 8 feet per minute. Okay, so again, in the context of the problem, right? Just think about if this ladder was sliding down the wall, right? If it was sliding down the wall, right? It's not going to slide down at a constant rate, right? You ever watch something fall? It kind of starts off sliding slowly, and then all, right? So that's what's happening. So when the ladder is 7 feet up the wall, it is sliding away from the wall at a rate of 7/8 foot per minute at that point in time. Okay? Okay. For homework, any questions on this one before I give you homework assignment? Okay. So your homework is in Google Classroom. And you're going to do numbers 1 to 5. This is due Thursday. Yes, this is due Thursday. Numbers 1 to 5. Okay, you can start working on that now so you can be asking questions. And then we will continue working on these Thursday. We will have a test next Monday. Okay. Test Monday. Any questions for me?